We're now going to look at section 3.3 and we're going to look at fertilizers. So what exactly do we mean by the term fertilizers? Well, we're talking about substances which restore to the soil nutrients necessary for growth. Now, the main nutrients that we're interested in are P and K. So phosphorus, nitrogen, potassium. So a fertilizer should contain some of these nutrients, and the compound containing these nutrients should be soluble in water, because the fertilizer is taken up through the roots as they take up water from the soil. So we need to produce soluble compounds containing phosphorus, nitrogen or potassium. Depending what plant you're growing, you might want a fertilizer with lots of phosphorus, or maybe one with lots of potassium. But probably the most common fertilizer, the one that we're going to focus on, are ones containing nitrogen. So for the rest of this, we are going to focus on nitrogen-based fertilizers. And two very important compounds in the process of making nitrogen-based fertilizers are ammonia and nitric acid. Now, nitric acid is HNO3, and it's an acid that we've used a lot in the chemistry lab, whereas ammonia is not a substance we've used quite as much. So ammonia is NH3, and it's a colourless gas, a very distinctive smell, which dissolves in water to give you an alkaline solution. And I'll just do a few demonstrations of that now. Right, this is a solution of ammonium hydroxide, and it gives off ammonia gas. Now the ammonia gas has got a very strong smell. It's colourless, you can't see it, but it's got a very strong smell, as you may remember. But a good way of testing it is to look at the effect it has on a piece of damp pH paper. So here's my pH paper, and if I hold it above the bottle, you'll see it very quickly turns blue, because the ammonia dissolves in water to give me an alkaline solution, and that's a good test for ammonia gas. Another fun way of showing how soluble ammonia is in water is this apparatus over here. This bulb here is full of ammonia gas, and when I pull this plunger out, I'll suck a little bit of the neutral water into the bulb, and all the ammonia will dissolve in that water, which will create a vacuum and pull up more water, and the water will go bluey purple because it's alkaline. So here goes, see if it works. So you can see the ammonia is dissolving in the water and producing this nice alkaline solution. So that's ammonia. Now it's important you don't mix up ammonia with ammonium. The NH3 is ammonia, and when it reacts with something else like chlorine or fluorine or hydroxide ions, you produce an ammonium salt. So for example, NH4Cl would be ammonium chloride. So the ammonium is an ion, it's NH4+, and you'll find that in your data booklet in the table of group ions. So NH4+ is ammonium, ammonia is NH3. So where do the ammonia and nitric acid come into play in terms of making nitrogen-based fertilizers? Well, here's a flow diagram of how we make nitrogen-based fertilizers. So the source of the nitrogen in nitrogen-based fertilizers is nitrogen in the air. It's a cheap available resource. 80% of the air is nitrogen. So in the first step we turn it into ammonia, and we do this by the Haber process, and this involves the nitrogen in the air reacting with hydrogen gas produce ammonia. Note that it's a reversible reaction, so as the nitrogen and hydrogen combine to make ammonia, at the same time the ammonia is breaking down to give you nitrogen and hydrogen, and this is just an example of what we call a reversible reaction. In order to get this reaction to take place, we need to use a catalyst, and we use an iron catalyst for this process. It's important you remember the name of the catalyst used. The ammonia then gets turned into nitric acid, and the name of this process is the Ostwald process. It takes the ammonia, reacts it with oxygen and air to produce nitrogen dioxide gas, which readily dissolves in water to give me nitric acid. Again, a catalyst is required. In this case, it's a platinum catalyst. Okay. So, as I told you when we were doing this in class, remember the alphabet: H for Haber, H-I, and M-N-O-P. So, iron for the Haber process, Ostwald processes use a platinum catalyst. Now, the platinum catalyst has to be hot, which is a problem in the industry because heating things up costs an awful lot of money and usually results in the product being very expensive. However, as I'll demonstrate in a minute, when the ammonia and the oxygen in the air react together with the it produces a very exothermic reaction, produces an awful lot of heat, and that generates enough heat to keep the platinum catalyst warm, and so we don't need to buy in the energy that's provided by the exothermic nature of the reaction, which I'll just demonstrate to you here. Right, this is a representation of the Ostwald process in which we make nitric acid from ammonia. In here we've got ammonium hydroxide solution which gives off ammonia gas, and it will react with the oxygen in the air to produce nitrogen dioxide, which can then dissolve in water to produce nitric acid. To get it to react, however, you need to use, I don't know if you can see this, it's a platinum catalyst, and you need heat, which of course is expensive. But the great thing about this reaction is it generates its own heat. You need to get a wee bit of heat to start it off, so I shall heat up my catalyst. Okay, now if I put it in here, see the reaction of the ammonia with the oxygen is really exothermic, so it produces enough heat to keep the catalyst warm once you've done that initial heating up process, and that makes the reaction very cheap. So even if I take it out, I can put it back in, and the exothermic nature of the reaction heats up the catalyst again and keeps it going, making the reaction cheap and giving you cheap nitric acid. Okay, so we made our nitric acid by a combination of the Haber process and the Ostwald process. We can't just put nitric acid onto soil because it's far too acidic. So we turn it into a soluble nitrate salt by a neutralization reaction. So most reactions involving acids are going to be neutralization reactions. So we do react the nitric acid with a base, so a metal oxide, a metal hydroxide, or a metal carbonate. To produce a soluble nitrate salt, which can then be used as a fertilizer. Finally, in this section we looked at how to work out percentage composition by mass. So, if you're given a compound and asked what percentage of it is nitrogen, you work out the mass of nitrogen in the formula, divide it by the granular formula mass of the compound and multiply by 100. In your data booklet, this equation is slightly simplified. It's just mass over GFM times 100. I think this is a more useful form of it, but this is what you've got in your data booklet. So let's do a quick worked example. Calculate the percentage by mass of nitrogen in ammonium nitrate. There's the formula for ammonium nitrate. Okay, so M here stands for the mass of the element. So percentage nitrogen. So the mass of the element in the formula. So let's just work through the formula. So we've got 14 there. 4 hydrogens is 4. Another 14 for the nitrogen. And 3 oxygens is 48. Okay. And you add them all up, it comes to 80. So the gram formula mass is 80. How much of that 80 is nitrogen? Well, that and that is nitrogen. So 28 is nitrogen. Divided by 80 times 100 and you get 35%. So ammonium nitrate contains 35% nitrogen by mass. So 4 things you must be able to do. Explain why fertilizers are required and the properties. Remember the 3 main nutrients that soil requires. Describe the various steps in the production of nitrogen-based fertilizers. So Haber, Ostwald, neutralization. And carry out percentage mass calculations.